Hello, thank you for checking out A1 Math, and today we're looking at constructing exponential functions. And really what we're doing today is taking a look at a exponential function and plotting some points and just graphing it, okay? So what I want to do before I get into that is to talk about linear functions versus exponential functions and talk about some of the differences. So here we have a table for a linear function and a table for an exponential function. Okay, so with a linear function, if you look at the x values, as you plug in each value, you get this for your y. And you can see the difference between the two is 4. So every time you plug in 0, you get 2. When you plug in 1, you get 6. It's 4 higher. Then when you plug in 2, you get 10. It's another 4 higher. So you're adding 4 to each one. Even though when you plug it in, you multiply, you're adding 4. 4 is the difference between each one. Okay, and it gives us this y equals mx plus b base formula. Exponential, instead of adding, it's multiplication. So the difference between each x value there is you got 0 to 1, 1 to 2, 2 to 3. The output is a multiplication. So 2 times 3 will get us 6. 6 times 3 get us 18. 18 times 3 will get us 54. Okay? And the way that goes up is instead of multiplication, it's going to be with an exponent. So if you ever heard of the term exponential growth, notice how quick it goes up when you're multiplying there. So the base formula for linear is y equals mx plus b, with your x and your y coming from your points, and your m and your b being your constant numbers that you always have. Well, it's going to be similar with an exponential equation. You have y is equal to a times b raised to the x, or you can have the b in parentheses. And you'll still have those will be your constant numbers, and you'll have your x and y value which you plug in. So again, that's the difference between linear and exponential. What I want to do today is go over just a couple of problems and just graphing them on a graph with the function already given. Alright, so here in this problem we have the function already given, and it's 3 times 2 raised to the x. And they already give us the points that we can use to plot and figure out what our y or fx is going to be. So I'm going to go ahead and write the formula here. F of x is equal to 3 raised to the second. 3 times 2 raised to the x. Notice that's similar to our y is equal to a times b raised to the x, with the 2 being the b and a being 3 here. And just like we did with linear functions, we're going to take each one of these and plug them in. And since I have function notation, I'm going to write in whichever one I'm doing at that time. So the first one I'm going to do is -2. So I'm going to have f of -2 is equal to 3 times 2 raised to the -2. Now I'm going to go ahead and, like I said in a video telling us how to work with our exponentials, what we want to do is, since it has a negative exponent, we're going to drop this part into the denominator. That's going to leave us with 3 over 2 raised to the second. And that's going to get us 3 to the 4th, or 3/4. All right, now we're just going to move on along. We've got the -2, which is 3/4. I'm going to go ahead and put that in here. And we got f to the -1 is equal to 3 times 2 raised to the -1. Okay, and that's going to get us 3. I'm going to drop our base down here and make it a +1. And that's going to equal 3 to the second, or 3/2. So I could put 3/2 here, but I'm going to go ahead and change this to a mixed number and divide the 3 by 2, and that's going to get me 1 1/2. And you'll see why in just a minute. Okay, next I'm going to go ahead and do f of 0. It's going to be equal to 3 times 2 raised to the 0. All right, so 2 to the 0 is 1. That's going to be equal to 3 times 1. And that's going to get me 3. So when I plug in 0, I get 3. And now I'm going to have f to the 1 is equal to 3 times 2 raised to the 1. That's going to get me 3 times 2, which is equal to 6. So when I plug in this 1, I get 6. Notice how quick it's going. 3/4, 1 1/2, the 3, the 6. Now we're going to plug in 2. So I have 2 raised to the second. That'll give me 3 times 2 to the second, which is 4, which will give me 12. So when I plug in 2, I get 12. Okay, now I'm going to go ahead and graph this here. And you'll see it won't be a straight line. It's going to be a curve to it. So I'm going to start with -2 and go up 3 1/4. Now, got to pay close attention to your graph. Notice how here it's in halves. 1/2, -1, -1 1/2, -2. But here it's in 2s. 2, 4, 6, 8. Okay, so I need to go 3/4, which is like 75% of 1 whole. So since the 1 whole is half, I need to do just a little bit less than that for -2. And next I'm going to go ahead and do -1. And -1 is 1 1/2. So remember, half a block here is really a whole. So I do half of that half, and that'll be about right here. Next, I'm going to go to 0, and then go up to 3, which is about right here. Okay. When I go to 1, it's all the way up to 6. which is here. And when I go to 2, it's all the way up to 12. Okay. And then you draw a line the best you can. And this line will keep going, it'll never cross. It just gets smaller and smaller without crossing this line here. Okay. And that's the exponential function. Okay, let's take a look at another video. Sorry, another problem. All right, so this one we have a fraction. And everything remains the same. We're just going to go ahead and plug in our values and see what we get. But it doesn't give you the numbers that you need to add. You have to pick your own numbers, okay? And the best thing to do is take a look at the graph that you're given and go off of that, okay? So the first number I'm going to start with, and it would make sense to start out here since they give you so much graph, but being that I've already worked this, I know what's going to happen. I'm going to start with -1. Okay, I'm going to start with -1 and plug that one in. So I'm going to rewrite the equation over here. Y is equal to 3 times 1/2 raised to the x. Okay, and I'm going to plug in my first one, which is going to be -1. And I'm going to make a little chart here. So when I plug in -1, I get y is equal to 3 times 1/2 raised to the -1. And remember, when you multiply by -1 for your exponent, you're going to flip your equation here, or flip your fraction. That's going to get you 3 times 2 over 1, which is 2. And then 3 times 2 would equal 6. And that's way up here. So if I would have did -1, that would have been off the chart here. I'm sorry, -2, that would have been off. So anything right here would have been off my graph. So I'm going to go ahead and put -1, which is 6, and plot that out now. All right, now I'm going to do another one here. Y is equal to 3 times 1/2, and my next point I'm going to use is 0. So 3 times 1/2 raised to the 0. And anything raised to 0 is 1. So it's 3 times 1, which is equal to 3. All right, so when I plug in 0, I get 3. I'm going to go to 0 and go up to 3 here. All right, now I'm going to go ahead and plug in this next one here. And that's going to be 3 and 1/2 raised to the 1. Equal to 3 times 1/2, which is equal to 3 over 2. So when I plug in 1, I get 1.5. And I'm going to do one more. Y is equal to 2 times 1 over 2. Sorry, y is equal to 3 times 1/2 raised to the 2nd. Which would be 3 times 2 times 1, which is 2, and 2 times 1, which is 1, and 2 times 2, which is 4, equals 3 1/4. So I get 3 1/4 there. And what happens there is I'm going to go ahead and graph. So at 1, it's going to be 1 1/2. So at 1, it's 1 1/2, about right here. And at 2, it's 3/4, about right here. And what happens, it'll keep on going down off the graph, like so. So notice when you have 1/2, it goes down, and when it's a whole number, it goes up. Let's taking a look at constructing exponential functions. Thank you for checking out A1 Math. Have a nice day.